Okay, Bismillahirrahmanirrahim. We start our lesson today with the properties of propositional logic. This one I think you have learned in a discrete structure, but for the following is the revision. Revision for every operations that you have learned. Okay, in logic, the following operation are the start recording. Okay, the following operation is very important to to understand the properties of the logic. Okay, okay the first one we go for the implication. Implication operation. Okay, implication in logic. In logic, implication is a relationship between two propositions. You need to validate the proposition first, and then in which the second is the logical consequences of the first lah. Okay. For example, here we have implication negate A or B is equal to A implies by B lah. The conception of implication is based upon the meaning of proposition. Basically, it's not merely upon their truth or falsity lah. Okay. Okay, an example of implication in logic is the policeman connecting a person to a crime even though there is no evidence. Okay, this one is the implication example. Okay, okay, then the symbol implication implies to mean this from here on out. The element of the propositional logic like implies that we add to our language in order to form more complex sentences. Okay, for example, here we are connected through the truth functional connective. For the conditional, the input of truth value and the output is one truth value. Okay, we have implication. Okay, this one implication. Okay, sometimes we call it as a truth connective functional. Okay, and then secondly, we are looking for the contraposition. Contraposition in the logic. Okay, first we go by the implication, and then secondly we go by the contra positive or contraposition. Okay, for the contraposition is a form of immediate inferences in which the proposition is inferred from another and where the former has its subject the contradictory of the original logical proposition predicates. Okay, this one for the contraposition is basically is a form of immediate inferences. Okay, contraposition. For example, if we have A implies B is equivalence of negate B implies negate A. Okay. The law of contraposition says that conditional statement is true if and only if it is contrapositive is true. Okay, contrapositive means you add the negation element into the implications. Okay, and then the contrapositive can be compared with three other statements. that we call it as inversion. Inversion. This one you have also learned in a discrete structure. For example, if it is not raining, then I don't wear my coat. This one is contraposition. Okay, we have contraposition, conditional statement, conditional statement is true if and only if IIF, okay, is contrapositive is true. Okay. Okay, normally when you are using contrapositive, you added the negation. You added the negation. Okay, this one is for contraposition, conditional statement. Okay, for example, if it is not raining, then I don't wear my coat lah. Okay, you add the negation. Okay, is it okay? Afif, boleh ke? Afif, boleh eh? This one you have learned in a discrete structure. Okay, we have looked into two properties of professional logic. First one is implication. Second one is contraposition, and the third one is equivalences. Okay, the equivalences for the logic equivalences, you can see that A implies B and B implies A is equivalent to A implies B. Is biconditional of B. The statement of P and Q are said to be logically equivalent if they have the probable form from each other under a set of axiom or have the same truth value in every model. Okay, basically for the logical equivalences is type of relationship between two statements or sentences in professional logic or sometime in a Boolean algebra. The relation translate verbally into if and only if IFF and has been symbolized by double line, double arrow pointing to the left and the right. Okay. This one is equivalences. Okay. Okay. This one is the symbol of equivalence. Okay. Specifically between two statements or sentences in the professional logic or Boolean algebra. Okay, what is the example? Consider the following statement. If Ryan gets a pay rise, then he will take Alison to dinner lah. Okay, this means that we can say that if Ryan does not take Alison to dinner, then he did not get a pay raise is logically equivalent lah. Okay, meaning to say that if sequences of A is occurred, then B you can infer logically. Okay. Okay, in logic, the formation of proposition form from two other which are linked by the phrase if and only if, and then the equivalence form from two proposition. Okay, we can have A and B, and also may be defined by the statement A is necessary and sufficient condition for B. Okay, that one is implication, contraposition, and equivalences. Okay, equivalence. And then thirdly is De Morgan law. De Morgan law. You have a lot of De Morgan's law applied to the formal logic. In propositional logic and Boolean algebra, De Morgan laws are a pair of transformational rules that are both valid rules of inferences. Okay, a valid rule of inferences, which mean that they have a both valid rule of inferences. Okay, the rule of inferences allows the expression of conjunction and disjunction purely in terms of each other via the negation. Okay, we have negate, for example, we have negate A and B by the conjunction. Okay, we also equivalent to negate A or negate B. Okay, okay, and then we have conjunction uh, after we get by the De Morgan law, it have by the disjunction. Okay, same goes by the A or B. A or B, we negate and then is equivalences to negate A and negate B. This one is De Morgan law. Okay, the pair of transformational rules that are both valid rules of inferences. Okay. Okay, I have explained four. Okay, first one is implication. Second one is contraposition. Third one is equivalences, and fourth one is De Morgan law. Okay, and then fifth one is distributive law. Distributive law. Okay, as you can see for the distributive law, okay, is the law relating the operation of multiplication, okay, and addition. Okay, that meaning that the monomial factor is distributed. Okay, for example, here if we have A or B and C, we can get the A into the operation of the outer bracket. Okay, this one is monomial. For example, okay, if we have A, sorry, have A, B plus C is equivalent to AB plus AC. This one, the loop, the outer loop. Okay, this one is bracket in the bracket. Same goes here. For the distributive law, we have A or B and C, and then we have A or B and A or C. Okay, and then this one is for disjunctive. This one for the conjunctive. Same. Okay, that one is for distributive law. And then we have a tautology. Tautology uh, in logic is basically is a formula or assertion that is true in every possible interpretation. You must have the truth value. You can have the tautology either in the you define uh, the contradiction in the truth table, and then the output will be all true. Okay, and then example is simple. Either the ball is green or the ball is not green. Is always be true. Okay, this one is tautology, and then we have contradiction. Contradiction in a traditional logic, contradiction occurs when a proposition conflict either with itself or with established fact. It is a proposition that unconditionally false. For example, if self-contradictory proposition that can be generalized to collection of proposition which is then said to be contain contradiction. Okay, we have A and negate A. Okay, this one is contradiction, tautology and contradiction. Okay, okay, and then for the example of contradiction, okay, for example, in terms of the gentle torturer, the towering with midget or the snowy summer days, a person can also express a contradiction, like the person who professes atheism yet goes to the church every Sunday. For example, another example, if you take the formal method, you dislike the formal method, but also you have been attended the class of formal methods. This one is contradiction. Contradict. Okay. And then we go continually by the satisfiability. Okay, a formula called satisfiable if the it is true for at least one interpretation. Okay, you need to have the one interpretation that satisfiable. Okay, okay, and then logically valid or simply valid if it is true for all interpretation. The true for formula are also called tautologies. And then it is unsatisfiable if it is not true for any interpretation. And then is satisfiable if at least one interpretation makes a formula in the true theory of true, and valid if every formula is true in every interpretation. Okay, and then propositional logic said to be satisfiable if it is a tautology or contingency. Okay, this one can be okay. This one can be two lah. Okay, tautology. The next one will be contingency. Okay, do you have any question for satisfiability? Okay, another example for the satisfiability. Okay, we have uh, this junction denotes the set of all assignment. Okay, and then we have the recursion formula. Okay, okay, a formula mu. Okay, a formula mu is called a valid if satisfiable mu is called v. Okay, if this one also called as a tautology lah. And then a formula of mu is called satisfiable. Okay, if is equal to non-empty set. And then another formula, we have one, we have two, three. A formula is called unsatisfiable if mu is empty set. This one also is called contradiction. Contradiction. Okay, this one contradiction. Mu is called satisfiable if this one mu is empty set, and then it's called valid if and only if you have mu for the disjunctive. It's called tautology. Okay, and then okay, for the satisfiable, we have two here. Okay, this one is satisfiable. This one unsatisfiable. Okay, when you satisfiable, this one should be valid. Okay. Okay, this one is deduct theorem. Okay, we have a knowledge base proved by the entailment. Entailment. Okay, this one entailment is a subset of satisfiable. Okay, and then okay, for example, this one for the satisfiable, we can say that x1 and x2 implies x1 or x2. This one is valid. We call it as a valid statement. Okay, and then we have x1 or x2. Okay, this one implies x1. This one is satisfiable. Satisfiable. And then x1 and x2. Okay, and then we and negate x1 is unsatisfiable. Okay, okay, because we contradict the statement. We contradict the statement, and then the contradiction is unsatisfiable. Okay, and then we have entailment. Entailment is pragmatic in linguistic. Entailment is the relationship between two sentences where the truth of A requires the truth of another B. For example, the sentence of A, the president was assassinated, and entails B, the president is dead. Lah. This one for the entailment. Okay, basically is the relationship between two sentences. And this one is the relationship between two sentences. Okay, then you might ask, how do you represent the logical entailment? Basically, the logical entailment, you need a set of sentences called premises, and then logically entail a sentence called a conclusion. If and only if every true assignment that satisfy the premises also satisfy the conclusion. We have a conclusion. Okay, we have a hypothesis and conclusion. Okay. Okay, for the entailment is defined similarly as in propositional logic. If a model satisfies a universal quantified formula, and it also satisfies the formula whereby the quantified variable has been substituted with some of the terms, and then the prescription is to use all the terms which appear in the table. Okay, and then you might ask what is the purpose of entailment. Entailment is a system inheritance that limit the inheritance to specific objective. Okay, okay, and then we have sound. Sound in calculus is called a sound if every derived proposition follows semantically. Okay, semantically, that is if the whole formula of knowledge base and Q that KB Q, then KB is equal to Q lah. Okay, this one for propositional proposition. Okay, and then this one for the definition in deductive reasoning, a sound argument is argument that valid if is valid and all of the premises are true. Okay, and then a calculus is called complete if all semantic of consequences can be derived. That formula in knowledge base and Q is following holds the values. That one is for the sound, and then we have the CNF conjunctive normal form. Okay, conjunctive normal form. We have the clauses. Okay, K1 and K2 until Kn. Okay, and then the clause of Ki concept of disjunction must have disjunction of literal, and final literal is a variable. Basically, we require a positive literal or a negative variable or negative literal. Okay, for the conjunctive normal form is a proposition is another canonical form that may occasionally be useful, but not the same degree as the disjunctive normal form. We have DNF and CNF. As the name should be suggest after our discussion before this, the conjunctive normal form of a proposition is the equivalent form that consists of conjunction of disjunction. Okay, it is easily constructed indirectly using the disjunctive normal form by observing that you negate all of the values of disjunctive normal form DNF. You get a conjunctive normal form. For example, three application of De Morgan laws. Okay, we use the De Morgan laws, and then for example here we negate P and negate Q, or negate P and negate Q, that equivalence to negate P or Q and P or Q lah. Okay, this one is using the conjunctive lah. Okay, okay, conjunctive is similar to you put the conjunctive by this disjunctive here, the operation here, you compound the, okay, compound the two proposition. Okay, do you have any question? Ada soalan ke? If you don't have